Hello and welcome to Beginner Programming. Today I'm going to be talking about Matlab. I'm going to be introducing the basic tools with which you can create any program you want in Matlab. Now this is going to be a longer video, so I have included the timestamps on this page as well as in the description for your convenience. Before I begin, I want to talk about Matlab itself. Now, Matlab is commonly used by academia and the sciences, and there's a very good reason for that. Matlab is a paid program. That means you need an annual subscription to get continual updates. However, Matlab does campus-wide Matlab licenses, and so it's very easy to get a hold of in academia. One major drawback from this is that because it costs money on an annual basis to get the newest version of Matlab, Matlab is intrinsically not open source. And so if you produce code within Matlab, it puts a hindrance on sharing that out into the rest of the world because it just simply isn't accessible. So why would we want to use Matlab regardless? For one, Matlab is very good at crunching huge amounts of data. If you have a matrix of tens of thousands of subdivided matrices, or it's a giant circulation model for the ocean, Matlab's a great program to be running and crunching all these numbers in. If you're doing something that's less intensive, say you're using it like a simplified calculator, Matlab's the same as every other program, and you can use other programs. There are alternatives to Matlab. There's Python and R, both of which are gaining traction and are open source. However, Matlab remains very common in academia, and it does have specialized uses which it is better than Python or R. So if you do have a case where Matlab is better for one of the other languages, or if you're on a project or you have legacy code that's already written in Matlab, Matlab is a good language to know. So let's begin. If you bring up Matlab, you'll see a window that looks sort of like this. Maybe not exactly, but it'll have the same basic things in every Matlab. For starters, you have a bar somewhere on your screen that says the directory, and this is the current folder that you are in. This is where Matlab defaults to for finding all the programs you're running, loading all the data, etc. You can see what's listed in this current folder on this left-hand page here, labeled current folder. Below it is a window that says details. So if I click on one of the files, this one just happens to be a .mat, which means it's a data file for Matlab, as opposed to a .m, which is a program script that you can run, just a list of code, or a .mls, which is a Matlab specific thing, which I'm going to be using for demonstration purposes here. But this is very important. Now you can navigate it. You can do all sorts of things, like creating folders, and then if you click on it, you can progress to that new folder. In the middle window is where you actually run code. So if you put a single command in, for example, if I say x equals 1, and I hit it, then it'll save x equals 1. Now this has a drawback that you can only run one command at a time, and we'll get back to this. Next, on the far right, we have our workspace, which is where our variables are saved. We just created a variable, x with a value of 1, and you can see that x with a value of 1 here. In the bottom, you can see a command history of what you've run in this command window. We've only run one command in this session, and so that was our only listed thing. However, it's inconvenient to only run one command, one line of code at a time. And because of this, we have scripts. Now, you open a script using either new script here or new drop-down script here, and it looks like this. And then you can type code, say x equals 1 here, and if I hit run, well, it's going to hit run section, you pass that, and it'll do exactly the same thing as we just did. So I'm going to discard this. Now, before I get much further, I want to point out that if you click on any of these windows, you can move them around. So I can drag this to whatever spot, or I can pop it out completely, and now you have it in front of you. If you ever get into a situation where a window pops up like this and you don't know what to do, if you hit this drop down arrow here and hit dock, it'll return back to where it was. You can get anything that you rearrange back to where it was by docking the main menu. So we're going to start by opening up just code that I've created, and you can see it has a lot of things in it. In order to make this easier to run, I want to clarify that this is entirely for demonstration purposes. I have a duplicate that is as a live script. Now what this does, if I run this first section here, it's created a bunch of variables, but because I have these semicolons, if I remove these semicolons, the semicolons suppress the output. So if I remove the semicolon and I hit run, then each one of them will do it. If I'm not stepping through the program line by line, this other program allows me to easily do that, and this you can just create by new live script. Sorry, back in the home window, new live script. In terms of editing code, you're going to want to be in the editor, either with your normal code or with the live editor. And that's just because these run buttons are very convenient. The last window I want to introduce, besides this editor window, is the variable window. And if you click on any variable, it will show up here, just on the tab. So there's editor and there's variables, and you can see there's one number here. If I open up something else, you can see it's now filled in. And you can exit out of individual variables or things you can roll access. Okay, so let's start coding. Before I begin, I'm just going to clear our variables. So we can start fresh. And I'm going to hit the step button. And what the step button means, I'm going to run line by line. So if I hit the first thing, we're on line 1. And it has said I've taken a variable and I've named it variable 1. And I have saved it as a number. I have saved the number 2. I'm going to make this a little bit bigger. Then the next one is a string, and all it is I'm saving text as a variable. It's the same thing. You can also save variables as other variables. So I've saved 3, the 2 as variable 3. The next thing is a blank thing. So this is an empty array. So its size is 0 by 0, and that's just so that you initialize it, so you can use indexing on it. There's other ways that you can initialize an array and just fill in a bunch of blank values. You can fill a 3 by 2 of zeros, so it's got 3, which means 3 rows, and 2, which means 2 columns, and all of the values are 0. You can do the same thing for ones, and the same thing for NaN values, which is not applicable. It's a shortcut for saying there's no data or there's something bad with the data. So you don't want to put in a number like 0 because 0 can mean numbers. So Matlab uses n, capital N, lowercase a, capital N to demonstrate that. If you want a vector, so a continually counting chain from 1 to 10, you use a colon. You can also use another colon with a number in between to determine the interval you want to count. So instead of going 1, 2, 3, 4, it's now going 1, 3, 5 because there's a 2 here. Note that it doesn't have a 10, and that's because when it got to 9, so it started with 1, went 3, it couldn't complete that link. 10's only 1 away instead of 2, so it couldn't do that. So that's one important limitation of using this style of notation. You can also create a vector with variables or numbers of your choosing. Commas represent the next number in line. So if you have a 1, it'll put it in the first column. If you put a comma, that'll tell it to put it in the second column, and the third column, the fourth column. And so you're creating a 1 row by 4. These brackets demonstrate that it's an array and that you want to include multiple terms at once. If you use a semicolon instead, that means you want to be displaying them vertically, so you create a vector vertically. The same principle as the commas. Now, how Matlab uses arrays is you have to fill in a row and then drop down to the next line. So you do 1, 2, and then a semicolon to drop down to the next one. 3, 4, drop down, 5, 6. You can also do it for strings. Just make sure that the string is the same length. So I've chosen 2 3-letter words, they work as an array. If I chose a 4-letter word and a 3-letter word, I have to put in a space just to make sure that they're same size, because all arrays have to be the same size. Similarly, if I have variable 12 over here, a 3 by 2, I can add two elements below it using a new line there to append on the bottom of it. As long as I'm keeping the same size consistent with what it currently has, the current dimensions, and I'm not trying to add a single unit, I can add on more values. So this next one, I'm going to signify just more appending. I create the matrix. I append on a blank matrix, and this is what a blank matrix is used for. So now I've created a 1 by 2 on the blank matrix, and I can run it again. And we usually do this in a for loop or something similar. So now I have a 2 by 2. The next thing I'm going to talk about is indexing. So specifically, you have a matrix already. How do you access the numbers within the matrix? And the first thing I'm going to do is just clear it out. So we have two old variables that we're going to use, a vector as well as a matrix 1 through 6. The first thing is that you can put in the number of the cells. And how that works is, for the vector, it's very clear. You have the first number, and then you have the second number. It's a 2. For a matrix, it works slightly differently. Instead of counting 1, 2 over, it counts down. So it counts through the rows and then goes over to a new column. So I'd do 1, 3. Now you can effectively think about that the same as for variable 8 as well. It did the first column, 1, and then did the second column because there was only one row. So it's important to remember when you're doing this. Now, this is not a very intuitive way of thinking about indices, and so Matlab allows you to do something else. You can specify what dimension it is. So you can say row 1, column 2. And that will give us the same number, will give us this number in the upper right, which is what we were going for originally when we said 2. So now I'm going to initialize a new array of zeros just to show you how you can use this, and you can pick an individual value and set it equal to another value. So I'm just setting it equal to that 2 earlier, and so on the third row and second column there's a 2. I can also take, like we were taking those vectors before, I can take the first 3 values of, or the first 3 rows in the first column, and I can grab those from variable 12. Now this colon here is the same colon from here, except it's just saying get all the rows. I could use it similarly here to get all the columns if I put a colon here. So effectively, var 12 colon comma colon is the same as var 12. So this is the same thing, just showing that you can put an array, nest an array or a matrix within the indexing and it will work exactly as you expect. Now this shows that you can use end to grab the last value of a specific thing. So we're grabbing the last value of var 12, and just to remember, the last value of var 12 is, the last row is a 5 and a 6. We want the first column, which is a 5, and that's putting it at 1, 1. So we now have, instead of a 1, we have a 5. Basic thing, but we have to talk about them. Next is just to identify the longest dimension, and so if you have a vector, this is effectively the longest side. And so if we use it for our matrix, if we used it for variable 8, it would be 10, because it's just counting 1 through 10. It would be a size of 10. However, for our matrix, it is 3, because, and we're using this matrix, so it's 1, 2, 3. The biggest side, effectively, is the number of rows. If we want the specific dimension, we use size, and that'll tell us it's a 3 by 2. We can also specify which dimension we want, and that will give us a 2 by putting it in this thing. So the first is rows, the second is columns, the third would be whatever third dimension you have, or nth dimension, because MATLAB puts no constraints on what dimension that you have. So here's what happens if you initialize an array and you just pick a number that doesn't exist yet. MATLAB will fill all preceding numbers with zeros. And this also works if you have multiple dimensions. If you put a 3-dimensional thing and you put a 5 in the 3rd dimension, then we'll fill the first, all values before it with zeros. So here I'm showing what a 3-dimensional matrix looks like in MATLAB. It will show the first level and then the second level, and if you did 4 dimensions, it would show you the first level, the second level, and so on with white space like this. And I'm just going to specify what I mean by white space versus normal. Here is a 3 by 2, 4 by 4. You can see that they're clearly listed, and then here's a 3-dimensional, so it's 3 by 2 by 2. If you open up a 2D matrix, it has that nice spreadsheet, but if you open up a 3D matrix, it now has a white page because it's just enumerating them down to keep track of everything. And so we have 2 matrices. Now I rushed past that a little bit. How you create, so we originally had zeros. If you want to fill in values on a 3rd dimension, you can't easily just pass them through like you did for 2D. You have to specify per each dimension filling in those values. You can't just use an array because of commas and semicolons do multiple dimensions. You have to pass it on in some other technique, and the technique that I use is just using colons and specifying the 3rd dimension. You can also do that by just defining it without putting in blank zeros originally, and just appending the additional dimensions as you go. And that's useful if you're doing something like transects and you want to combine multiple transects after each other. You can use multiple dimensions as needed. So now I'm going to talk about some useful mechanisms for matrix manipulation. And here's just a reminder of what variable 16 was. That was just the blank matrix that I put a 5 at the end. If you transpose it, so you use this, and my apologies, I forgot to delete the semicolon. I'll just place it down here. If you transpose it with that apostrophe, it will now invert the rows and columns. So if it was a 3 by 2, now it's a 2 by 3. I can also use flip up down, and that will take, and this is the 3 by 2 by 2 matrix that we were just looking at. It will invert all of the matrices so that what was the last row is now the first row, and vice versa. It's flip up, UD just means flip up down, and there's a similar command for left right, which now flips it, so the last column is now the first column, and vice versa. And it will flip all the way through the range. It doesn't just do 2 columns. So now, talking about operators and statistics, this is really simple, so I'm just going to skip past it. If we have a matrix, we can add, we can subtract, we can multiply, and this is important because dot, it doesn't do matrix multiplication, it does cell by cell. So if we have variable 20 here, which is just variable 19 times plus itself, you have 1 times 2 is 2, and 3 times 6 is 18. This is not matrix multiplication where you're adding up. If you did matrix multiplication, so you didn't put that dot, you get a very different answer. And this is important because cell by cell requires the matrices to be the same dimensions. So a 3 by 2 dot multiplied by a 3 by 2, whereas matrix multiplication has to follow the rules of matrix multiplication. So a 3 by 2 has to have the next matrix with the dimensions, a row dimensions of 2. Also note that you can use dot star for 3-dimensional matrices very easily, whereas I'm not entirely sure if matrix multiplication works for 3 dimensions or if there is a practical reason why you'd even want to do that in the first place. You can also do that for division. Just note that the directionality of your slash determines what's being divided by what. If you do a backwards slash here, you are now having 20 as the numerator and 19 as the denominator instead of the opposite. And of course there's matrix division. For powers, there's also dot, so cell by cell versus non-cell by cell. If you want to do any powers, you just change out where that 2 is and you put in parentheses, as is displayed in the comment of this section. I should note, I don't know if I actually noted this beforehand, but a comment, if you put this number, this percent sign, it isn't running anything in green. That's not being run. Similarly, if you have a double number sign like this, a double percent sign, it's a section that's treated differently in the base code here. So I can skip to the next section when you're actually doing your coding and you're not doing this live script, and it all writes in yellow. It's very easy to find where you're doing. Similarly, these comments don't actually run. I am bringing this up because, well, let me finish with the statistics first. So then there's the common things. There's mean. Oh, there is a square root function if you don't want to run square root to the 1/2 or root raised to the power of 1/2. There is a square root command. It's unique to square root though. And that does do cell by cell, not matrix. there's a mean command, and you can specify what dimensions. So here I'm doing a variable 19, and it is averaging 1 and 2, and 3 and 4. It is not averaging the opposite, and that's why it's averaging rows instead of columns, because yeah, I screwed that up, sorry about that. It's averaging rows, not columns, because of the second dimension. The default is by columns instead of by rows, and it's the same for standard deviation, except you can't specify it. It's always going to be by columns no matter what. You have to use one of the transpose, or just modifying the array if you want it to be as a standard deviation. Then we have minimum and maximum. My apologies, I made a typo. This minimum value is, you're not supposed to have a 2 in it. If you did do the value of minimum, it'll show you this first row, and similarly if I do the maximum, it'll show you this second row. It shouldn't have these 2's around it. Now if you wanted to get the index of it, they'll tell you it if you do so if you want to use it, this maximum and minimum come as functions that you can get multiple outputs. This 2 and 2 that you're seeing, those are the indices that are coming out of it. Specifically with the maximum command, for the minimum it should be 1, 1. So it's shaping it as a vector, the first of the maximum, the actual values, what is the minimum value or maximum value, and then the indices within the column. So for var 19, it is row 1 is a 1, row 1 of column 2 is a 2. That's how they're read. If you wanted to do further manipulation about this, so I've created a vector. Abs is for finding the absolute value. So if you run it, it now has made all the negative values positive. If I use round, it's going to round up or down based on, I think it's 0.5. I think 0.5 is always rounded up, and that means towards increasing. So if it's effectively rounded down as a negative value. So you can see what it treated that as. Floor means always round down, and seal means always round up, and you can see how those compare. Now we're going to talk about logic, and this is a method here, this %, curly bracket, is a way that you can use a multiple line comment, so that you don't have to put a % all the way down the list. You can use this bracket instead. Now what each of these syntaxes are, you can read the list. The important thing is that this is a tilde equal sign. Otherwise it's pretty conventional. The equals is necessary so that MATLAB knows that you're trying to see whether it is equal rather than calling a new variable. Also important, if you see an and, that means and, or an ampersand, that means and if you see a vertical bar, that it means or. Occasionally, MATLAB will want you to use 2 of them, particularly in if statements or other various places. It will flag up a warning and tell you to do it, so you don't have to really remember it. MATLAB will keep track of it for you. So we're now going to see how you can use these logicals to find a specific value. And so if I have a vector that goes from 1 to 10 and I want to find 7, it's going to be the 7th place. Now note, this is not the dimensional indexing, and same with the min or max. This is not dimensional indexing. This is specifically that one where it goes 1, and then it'll count down through the rows and then go to the next column and then to the third dimension and fourth dimension. It's just important to remember that when you're piecing back together where in the matrix the value you got was. Now if we wanted to find 2, so we're using an or stand, it's finding the number that equals 3, so 3, as well as the numbers greater than 7 or equal to 7. Now note these are still returning indexing. They're not returning the actual values for those numbers. If you wanted to find those numbers, you would do this. So you've taken the find, so you've taken the indexes, you've put them back into the original matrix, and you've saved it as a new value. Now, if you wanted to do this efficiently, and MATLAB will give you a warning every time you write it like this. That's what this squiggly line is. MATLAB says, it isn't efficient. This is not an efficient way of doing it. You can instead do this, where if you just tell it a logical, it'll produce a logical array. And this is what is known as a Boolean. It's true-false. Every 0 is false, and every 1 is true. And so if you plug this in to the same array, it will do that truncation. And so the new variable will just have the terms where that is true. Now, we also can do logic with if-else statements. So basically giving different commands to the code based on what the logical, whether it's true or false. So we have a variable here, which I've defined it as 2. If we step, yeah, it's 2. Now it's only going to run where it's true. So it steps here and it says, okay, it's 2. So save a new variable. And then it does not run else if or else because it found something that was true. Similarly, if we try this with 3, it'll step, it'll try if, it won't happen, so it will not step in. It'll now try else if. This is true, so it will step in, and then after it has finished doing this, it'll jump to the end. It's the same with the next line. If we have a line here, it'll try the first one, it'll fail, it'll go to the next one, it'll fail, it'll go to the third one. Now else means everything that doesn't meet the prior conditions, it will do. And so it does it. Now you can also do it, now I also want to clarify that you don't need else if or else. You can just say if something, do something, and then end. That works perfectly fine for syntax. You don't need the else if or the else unless you want to. Now the next thing that we're going to talk about is loops. So specifically you have a code that you want repeated a bunch of times, so you aren't doing this where you're repeating the same code 3 times with different inputs. You want to just input your value. So for demonstration purposes, I have a value. I've made it 0, so I've initialized an array, and I recommend initializing array always because it'll make it easier, and it's easier to tell if your code's working as intended. And so we have an array of zeros, and now we've set I. This is our index. This is what it's looping through. This value's here. It'll do it once for every single value. So if I make a 3-dimensional, well, frankly, it works a lot better as a vector. I don't even know if it runs on multiple dimensions. I think it only runs in 1 dimension. And so it'll count through 1, and it'll try this, filling all the i's with 1, then it'll go to 2, then it'll go to 3, all the way up to 10. And what that looks like, see, it's done through the first loop, and it's filled in a 1. Then it'll stop on there, put in a 2, and it just keeps on doing this each iteration. You see it looping through the for loop and filling in 1 additional number each time. So we're on 6 now, 8, now onto 10. And so you can see for each loop, it added and filled in one number all the way through. Similarly, if we have a random vector where I've specified 6 numbers, and I filled in 1 through 10, it's now going to loop through those numbers, check to see if it's greater than 3. If it is, then it will put in a number, and so see it found 1 on the 4th position. It found another on the 5th position, and then it found nothing, and it moves on. Now all these trailing zeros is because I initialized it with 10 zeros instead of the length of this. If I had done, it would have been more efficient if I had done 39 equals zeros 1 to length var 38. Sorry, I forgot a parenthesis. And then we would have gotten exactly the same number. And this is the reason why I actually think that this is a good practice, because it forces you to really look closely at what you're determining. You can just, if instead of doing this, you can initialize, if we had wanted to, we could say var 39 equals a blank array. Oops, sorry. Before we started, and it would just fill in whenever it came up with it. So if I ran this same thing here with a blank array, it's going to run perfectly fine. However, it is now 1 short. So it all depends on what you're trying to do. So now I have a initial array, and this is all this is doing is demonstrating a loop that instead of putting a set variable in, you can put a variable, and so it just looped in and put values in the same as before. Now this is a while loop. The for has a set limit. It will run through each of the values here, in this case 3 values. It'll go through 3 times. No matter what you do to I, no matter what you do to var 40 in this case, that's not going to change it. Whatever it's set up as, it will run 3 times with those 3 numbers as I. A while loop does not do that. It has a condition, an initial condition, and as long as that condition is not, while that initial condition is still true, it will run. So here I have var 42 equals 1. And I have it counting up by 1, so it will eventually go past 7. Now it's important to do something like this because while loops can run forever. If I said instead -1, it would keep on running until I stop the code. Now this is a useful thing. If you ever get into the point where you're running a code, you can hit Control-C. Control-C and this is in the command window here. So you have code running. Right now it's paused, and that's what this K is for. But you can use Control-C to break the code at any point in time. And it will just throw up an error and say aborted by user. So here's the while loop. It's going to just count up. Nice and easy. It counted up until 7. It went and checked this condition. It was now false. It broke. Similarly, if I've got 2 numbers, this is a more sophisticated thing. This is putting in a safety catch. So I've said here that what this is I have a condition. That's a very big condition. Whenever 43, it starts at 2, is less than 10 to the 9th, so about 1 million. Actually, it is 1 million. No, it's 1 billion. When it's less than 1 billion, then as it's multiplied by 2, so it's going to take a while to hit a billion, even if it's effectively adding and increasing power to it over and over and over again. But since I don't want it to take forever, I'm saying, well, okay, if I put in a 2, I don't want it to take all day until it eventually breaks over. I'm putting in a condition that says, okay, I run for this long and then give me a result. In this case, I have 8 iterations. And so this will run, it'll give me double it, and it'll say it's the first iteration, second iteration, and I'm going to hit this a bunch of times, and you can see it continually raising 2 to an additional power until it gets past 7 and it skips, so it went up to 8. And that's all this break does. This break just stops the loop early so that you don't have to meet the condition exactly. The equivalent if a function, if you remember this later, is return, where if a function will run until it hits return and then it gets kicked out. So now we have a bunch of numbers. What do we do with them? Well, if you're doing science or anything really, you want to be making plots of your numbers to show easily people what they mean. So I have 2 numbers here. I've got a column that I of the first numbers and a column of the second numbers. And if I plot them, so I just say Matlab plot them, I have 2 lines. And what these lines mean, and I'll put some labels on them. I have a title here. That's what the title does. X-axis, Y-axis is just X label, Y label, and I have a legend. And so what Matlab did is it said, okay, here's the indice value. So you've got, if I open up 45, all it did was use these numbers on the left here. So for column 1, it's a 1-to-1 ratio. Column 2, it's a 2-to-1 ratio. And it did that. If we wanted to find it, and even though I didn't put it on here, you can use slope. So slope of 2 numbers, or yn, I think it is, maybe. Or just use mx plus b, and it will tell you you can find the slope or the y-intercept of these graphs. Now, I sort of glossed over it, but figure you need to do in order to have it open up a new window. And if you're running normal code that isn't embedded, it looks like this. Does it run? Might not run in normal code. Did I break everything? I'm just going to skip back to. Okay, I just started this, so we're going to stop the code so I can show you what a normal figure looks like. Normal figure looks like that. So when you type in figure 1, it'll pop up a new figure and then you can plot stuff on it. So can I easily jump back into this? The answer is yes, I can. If I hover right over here, I can hit this. It'll run up until this line, and now it's highlighted. I can step forward. Okay, so now we have a second figure. Now we wanted, and this was the original plan, was to use the first column as X and the second column as Y. And you can do that just in the plot command by dictating to do that. What subplot does is it divides our figure, the one that I just popped up, and I will pull it up again. So if I hit stop, if we do figure, if we do subplot 221, what it's going to do for 221 is going to make a plot that it'll divide up this area here into 2 rows of 2, so the first number, and 2 columns. So it'll give 4 plots total. This third number is going to tell you the subplot number. Now, these do work in rows first instead of columns first like the indices, so it'll count 1, 2, 3, 4. And you'll see that in this plot here. And so it'll take a second to run forward until it reaches that point. And then we can step. And this is just going to plot it. And so it's plotted on the thing, and then we have it. So we've got column 1 versus column 2, and it's just a plain line. If we wanted to make it more interesting, we can convert it from a plain line, and I have a list of options that I put up on the screen here. If you use a star, as here, you now have just the same as how we had these two colors. You had a color for the first set and a color for the second set. Similarly, now it's there's a blue line and orange stars on top. And of course we have all of our things. Now an important note here is our legend automatically pops up over our line. If we don't want to do that, we can move the location. By default it's northeast. We can move it to northwest, which will put it in the other corner here. Now here we have a subplots. And all we've done is by putting the argument, well, we've done a couple things, and I'll run it so that you can see it completed. I'm realizing that maybe this markup is not the best for points. We've done two things here. The first is by specifying this B, that means that it is blue. We've also said we've only plotted the first one originally, so it's plotted a blue line. Then we said, no, wait, we still have more things to plot, and then plotted this over the already plotted plot, and then said, no, we're done. And you can do this as many times as you want. The hold on, plot another thing, and then hold off. Just remember to do hold off, otherwise if you plot another thing, you'll keep on adding to the already created plot rather than overwriting it, which is what it would do otherwise. So if we had a plain line here and we overrid it with this, and say we had a different plot, they would overwrite and replace rather than just show up on additional plots. Hold will keep it so that you can keep on adding stuff as long as that plot figure is open. This step here is just showing you how you can change the axes, and that's with this command here. And so now instead of it being 0 to 10, it goes from 5 to 8 and 8 to 15 or 9 to 15. And the reason why it is, so this is the lower limit of the x, upper limit of x, lower limit of y, upper limit of y. And these only works in 2D space, or it works for as many dimensions as are present. These are 2D plots. Okay, so that runs. Now this is an important method. If you open up the standard, and I'm actually going to just stop this and go back to normal code for a second. So here I'm going to advance through it until we hit plotting. Now I have all these semicolons here, so none of it's going to output. So I hit run. You can see what our output plot looks like. it's the same thing. This is what it actually looks like if you ran it in normal MATLAB instead of that run script. And what the normal background is this tan beige color in the background. What that command that I just recently brought up right here in our 3D plots is we're going to set it, the default is white. So if I copy paste it here, or if I alternatively, if you have code, you can right click and hit evaluate, it'll do the same thing. If I rerun this section here, now I have white plots, and that just makes it cleaner for copy pasting it onto Word documents or whatnot. You can change it to any color, so if I changed it to 0, 0, 0, and I evaluated this and I ran it, the background would now be black instead because MATLAB defaults to RGB values. And this grouped just means changing the default setting for all of MATLAB while it's open. Now, these 3D plots, I'm not going to go through them line by line. They're just supposed to demonstrate what the plots are. So I have two vectors here. I've created a mesh of it, and we'll go through slightly just to show you what they look like. So the bar is spinning, and here's what they look like. So I've created two vectors here, and using mesh grid, it's now creating a row of x values for us and a row of y values for us, depending on which you want to do. This is actually, I called them incorrectly. Mesh X is actually showing the y values and mesh Y is actually showing the x values, but it's irrelevant in terms of this. Mesh Z, all I'm doing is adding the two values together, so it creates something that starts at a low number at 1, 1, and it goes to the max value at end, end, or in this case 10, 10. So we have those. I'm going to stop this and go back to the plots that you'd be making in real things. And in MATLAB, if you put in the normal thing, if you click on these lines and hit run section, it's going to stop at those little dots, same as if I was doing the live script. And this is what's known as debug mode. That's why it says pause and debugger at the bottom right here. These red dots are debugging. You're pausing the code and you're not letting it run. So the first things I'm going to show is contour plots. And so if I continue through that, all I've done is plotted. Oh, and another point of interest, when you're doing labels in MATLAB, this uses a different language. It doesn't actually use a MATLAB language. It uses a language called LaTeX, spelled L-A-T-E-X, and that makes, in that language, underscore means subscript, and so our variables are changing names, and so that's just something that you can fix by putting a space in there. So our default plot is just contour. If we run through this, and I'm just going to plot them all, we get a plot that looks like this. So the first option is just our standard contour plot. The second option, I've now changed it so that instead of the default settings, I've said instead of making 6 lines, I said make 30 instead. So it's made 30 lines, contours, 30 contours. Contour F is a default of filled, and then I chose some special settings here where it said show text on them and fill off, and this is, you can create something that's similar to, say, bathymetry or elevation on maps. And that's a useful thing to be able to make. These next plots, I'm just going to hit continue, are 3D plots. They're both known as surface, and that's what this surf stands for. The first one, and I have to do these and these because I don't know whether you can use these settings. If you hit this button allows you to move them around. So you can see it's a 3D plot with X, Y, and Z. So X, Y, and Z. If you type it in and you hit view 2 like this, then it will put it in the perspective where, just show you, where everything's flat. And that's useful if you want to make a color plot that's interpolated with, just that looks like that. And I'll resume what it looks like. All you have to do is click on a subplot, and then hit a value, and then it'll go down. And that's important. If you ever plot something, right, where you have multiple subplots, you can either type in subplot in order to get to that figure, or you can click on it. And if I hit view 2 here, it will now resume it. Alternatively, I could type in subplot 121, and that would do the same effect as me clicking on it. Make sure it's the last figure you have clicked before with the new one, if you want it to change anything on your figures. Now, going back to our live script, after we used the 2D plots, we're going to clear, and this again clears all of our variables. So when we run this, it clears all our variables, and if we step again, it closes all the plots if we had them closed. This works slightly differently because the plots are displayed, so it doesn't do that. Now on to loading. So you can either load things two ways. The first way is you can do it by text like this, and this is referencing things in your home directory. So hit load example, it's going to load this example. You can see it's got 3 examples. Similarly, I can load it with the full path, so C, data, YouTube. This follows the syntax of your operating system. Or you can save it to a variable. In this case, because I've got more than one variable, it saves it as a structure. If I open up a structure, what that looks like is, instead of that nice spreadsheet or even the blank sheet with numbers on it, you now have to click on the additional number and it'll do a dot next to it. And what that means is if I take that temp, say x1 and x2, and you can click on all of them, and I set it equal, I have now just overwritten ax1 with the value from that temp structure. Similarly, if I make a new structure called struct, I can save how you access is you can put dot anything and it'll save as it. And it doesn't matter at all about what kind of data you save it in. It's all going to be saved because they're all separated. If you wanted to index anything in it, it's just standard indexing at the end after the dot. So for example, since I have 1, 2, if I choose that second number, it's a 2. If you want to save the values, variables in your space, if you hit save, this is going to save everything that's open currently in the workspace. So I'll hit step. I now have a thing called new data, which has all the variables, and if I step again, because I've specified this is the file name, these are the variable names, and so new data 2 only has 2 variables in it. Alternatively, if you're ever looking around and you want to save it, you can just hit save, and they'll give you a prompt. You can type in new data 3, and it will be the same as if I did new data. So now I'm going to talk about text and just general text commands. So earlier on in the beginning I sort of glossed over it, but if you use apostrophes on either side, that makes a string of text. So it looks like this. This is the string. If I use string to num, that takes that string and makes it a number. So variable 49 is now a number. If I take it, that same number, and I convert it back, if I use int to string, int looks for integers, so it truncates everything, all this 0.2311, so that it's just now 2,353. If I wanted those numbers to stay in my string, then I just use num to string, and you can see it converted exactly back to what I originally started with. The next thing is if you have text and you do have a semicolon at the end, it's not going to display when I save this. So just to demonstrate, if I copy paste this and I run it, nothing pops up because I have a semicolon. Well, how you get around that is by using display. So if I step this, it's going to say this is a string, and it will display that always. Now it doesn't have, and this is an important thing to note, you see how this, it gave the variable name and an equal sign and then a list of things. If I did text3 here, it will say text3 equals this. Display does not do that. Display just shows what the string is. And so it's very useful when you're doing coding because it creates very clean outputs during your code. So for example, here's a for loop, and I'm saying display what iteration we're on. So it says this is iteration 1. It labels it right there. And then it jumps through and says this is iteration 2. Another thing you can do with text is using eval commands, and what this just means is instead of writing the code itself yourself, you can now have another line write it, do it for you. So if I write this variable and I put it in here, what I get, well, I didn't actually, I left a semicolon in there so you can't see. So so that's what it says it was, and if I evaluate this, now you can see that it will give the same effect as if you just ran variable 51 equals 123. Now this is useful because you can, if you have multiple variables, like in this case, if I step, I have 52, 53, and 54. You can see them here. I put semicolons. You want to put semicolons if you're using multiple things on the same line to separate them. If you do that, and you run the for loop, now it's going to selectively, and since I put a semicolon, you can't see anything, but you can see them updating here on the right, where each time they run through, they update as 1, and instead of taking up, say, 3 lines to change each of them, well, I guess I'm taking up 3 lines anyway, but it does have potential for making your code much easier to read, and just save space when you're coding by enabling you to use more for loops. Another thing that's useful is blanks and deblanks. So if you have a matrix here, string, you can see that because of how I have it organized, because matrices have to have equal size, I had to put in a bunch of spaces to fill in the blank spaces between the difference in letter count between trees and other plants. If I'm taking these out to display with, I don't want to say trees because they'll leave this huge gap in it. And just to show what that looks like, if I have a thing that says these are text row 1, and then I put a period at the end, my apologies, text 6, you can see it leaves all that blank in there. Well, we don't want that, so we use dblank. If we take that step, you can now see it's removed all those blanks. If we run the same thing with text 7, it just runs straight. Similarly, we can, and that's just the same thing twice, I don't know why I did that. Similarly, oh, I remember why I was doing that. Now it's important to note that dblank does not remove the spaces between words. So, for example, other plants has left that blank in there. It only truncates the blanks off the end. Similarly, if you have blanks, blanks can be used to fill in space. It just creates an index of blanks, and this can be useful when you're adding stuff to a pre-existing string like this. I want to add the word animals, and I say, okay, well, here's my text that I want to add, and here's blanks, the size of the matrix, so the size of other plants, minus the length of my new string, and it just adds it exclusively at the end. The last thing I want to talk about is functions. Now we've been using them throughout this. This is what I'm, for example, mean is a function, standard deviation is a function, and they have inputs and outputs. But how do you make your own? Well, here I made a very simple function called add1, and I put it at the bottom of the file. All it does, you put down function, and this is important, functions have to go at the end of the file, otherwise they will not read, or they have to go in a separate file. Usually they're easier to put it in a separate file, or a separate script, sorry, so they're easy to refer to. So we have a function here. All it does is take the input, add 1 to it, and then save it as the output and return. So here we have add 1, and our answer is 2. The next one, we have a vector, and it adds 1 to every single thing in the vector. Now let's go for something a bit more complex. We have add 1 more, and we put an if statement where in another entry. So we have an input, and we have what number we want to add to the value, to the variable. In this case, we want to add a 2. So here we have input, num to add, and output. That's if everything works properly. But what if someone puts in, and if we run this, that's exactly what happens. We add 2 to every value. But what if someone goes and puts more than one value? Well, we have this if statement. It checks to see how many terms are in this matrix num to add. And we put in a catch that says if it doesn't, it can't add it. And then it has an output that's blank because we couldn't come up with an answer. Now, this also demonstrates an additional thing, so it does work exactly like that. It returns, it displays a value, and it prints a blank matrix. This also demonstrates how you put, since you're using apostrophes to create a text, to designate a list of letters as text, you need to put 2 of them in order to actually add a character for an apostrophe within your string. So that's just a appendum on that. This right here is what happens if you have an external program. So instead of having it here, you can just as easily create a new script. It does exactly the same thing. Just make sure it's on your path. And so when you hit stop, it does exactly that. It does the same thing as what originally did within the folder. Now, the important thing is it has to be on the path. So if I jump up here, which now the computer can't see it, and I hit run, it says it can't find it. And it'll tell me where it thinks it is on your computer, but it can't find it. Do the command like so, and then it will work perfectly fine. So that's the video. This should give you all the tools necessary to make any program, just combining if, else statements, combining for loops. You have all the tools to make all the variables that you need. Display will show you how it is, and I've provided a subscript of plots that you can use to plot things. The Matlab forums are very useful to finding out how to do things, and you can also use the help command. So if you highlight anything, say even our new thing, as long as we added a line of description, it'll tell you what it is. If you do something more useful, say deep blank, the pop-up toolbox will link you to a local wiki page and have all of the information that you need to do it. And so help is a very useful thing. You can also type it in here in the command window, and it will list off that same thing. So help is a very powerful command. Just one last note before I leave and I end this video, because it's already over an hour long. This code here I have with semicolons in. If I hit run for the entire code with all of our clears, sorry, this is because I had those debugging marks from earlier. If I run it, you can see that the only thing that happened were those display commands, and this is how you typically want your code to run, just because it makes it very clean and neat. Alright, have fun using Matlab. Please ask me any questions that you have in the comments below, and I'll try to answer them. Thank you very much for watching, and have a wonderful day.